So we have this crazy expression that we want to differentiate, and we can use quotient rule. Obviously, that's going to get very complex very soon. Well, what's the way to do it? Well, all of them has some exponent, x cubed, x minus 1 squared, and x minus 2 to the 1/2 power. So all of them are raised to exponent, and you only have product of things, and quotient of the factors. You only have product and quotient. Okay, so maybe we can use that. The exponent and product and quotient, that's making me think of natural log. That's making me think of logarithms. So why don't we try taking natural log of both sides? And the reason I'm taking natural log is because that's going to simplify this expression into something that we can differentiate more easily. I'm using more easily. That should be just easily. So let's simplify this. We can expand this expression, that's natural log of x cubed plus, remember, when you have multiplication inside natural log, you can split it up using plus natural log of x minus 1 squared. Now you're dividing, so you want to use minus. Natural log of square root of x minus 2, also known as x minus 2 to the 1/2 power. And for natural log, you can bring the exponent out front. So you have 3 times natural log of x plus 2 times natural log of x minus 1 minus 1/2 times natural log of x minus 2. And you know this thing is equal to natural log of y. So you know natural log of y is equal to this expression. So now let's differentiate this. Differentiating natural log of y with respect to x gets you 1 over y times y prime. And you have 3 times natural log of x, which becomes 3 over x plus 2 times 2 over x minus 1, and you want to differentiate x minus 1 and multiply by that. That's just multiplying by 1, so we don't have to worry about that. Minus 1 over 2 times x minus 2, and you differentiate x minus 2, which gets you 1, so you don't have to worry about that. So we know y prime is equal to y times this crazy expression, so y times this crazy expression. But you want this entire expression to be function of x, you don't want to have y. So instead of writing y, let's write our original expression. Our y was this expression. Let me try copying and pasting it if I can. So, if I can copy and paste it. So let's try that. Let's copy it. Let's go down. Let's paste it. So we have our y times, let me erase this arrow, times this expression, 3 over x plus 2 over x minus 1 minus 1 over 2 times x minus 2, and we're done. And this crazy expression didn't take us too long to evaluate. And this method, by taking natural log of both sides, then using the property to differentiate things, is called logarithmic differentiation, because you're differentiating using logarithms differentiation.